My name is Devesh Goyal. I work on the runtime development team at Esri. But just to get situated with who's in the audience here, how many of you here are new to ArcGIS Runtime, say less than 6 months or a year? Okay, about half of you. And how many of you are new to iOS development? All right, many of you. And will any of you be building apps with any of the other SDKs and APIs like JavaScript, Qt, .NET? All right, most of you will be. And finally, for how many of you this is the first developer summit? Okay, some of you, welcome. Just a word of advice, it can get quite overwhelming with all of the sessions and technology we have here, so don't feel like you have to understand everything when you leave. Just have some idea of what the roadmap is and where things fit in, and then you can always follow up with more questions after the conference. So this is the agenda for today's talk. I will be starting off with just an overview of runtime because this is an introductory session. We don't expect many of you to have used runtime, and so we'll give you tips and advice on how you can get started and what resources are available for you to use. Runtime has a lot of capabilities, much more than I could cover in one session or even two sessions. So what we typically do is have a session like this, which is very generic and general and is like a general introduction for most of you. But then we have deep dive on specific areas of runtime throughout the week. So we have a session dedicated to just working offline, a session dedicated to editing, 3D, working with content from portals, security. So I'll point those sessions out at the end of my talk so you can then figure out which ones you want to go into to learn more in depth on how to use those capabilities. But in this session, I'll keep it fairly high level. We will build an app just so you can see what it feels like to use the SDK and how you would build an app that displays a map and does some basic tasks like geocoding, routing, and I'll give you some tips along the way and point out some common patterns and practices you'll use in all of your app development. So ArcGIS Runtime is a tool for developers to build native apps. These apps can provide the best performance because they run really close to the metal and take advantage of all the power in the CPU and the GPU that's available on the device. You can use existing developer frameworks from platform providers like Apple, Google, Microsoft to build your apps for these platforms. You can use capabilities from ArcGIS Online or ArcGIS Enterprise, or some of these capabilities runtime offers locally on the device without needing a connection to any of those two things. And then you can build apps that work on a wide variety of devices and across all platforms and OSs like iOS, Android, Windows, Linux, and even embedded devices. And one of the key benefits of using runtime is that your apps can go offline and still be able to work with data and perform analysis even without a network connection. So the way we build ArcGIS Runtime is that we use C and C++. The reason for that is it gives us the best performance on the device, but also it's cross-platform and portable. However, we don't expose those C APIs to you because that would be very difficult for you to build in your apps. What we do is add a small veneer of APIs on top of our core development so that app development becomes very familiar to people who are building iOS apps or Windows apps. And these APIs are native to the platform and use the tools and resources that are available on the platform. The other advantage of building once in C and C++ is that we end up using the same conceptual model across all our different APIs and SDKs. So if you build an app with Android and you start building with iOS later on, you'll see a lot of the same capabilities and patterns because they're all coming from deep within runtime. Currently, we're on the 100X series of releases for runtime. This is a new generation of runtime that we started developing a little over 2 years ago. And in the past 2 years, we've had a number of releases that have added capabilities and improved quality. So the first release was built on this new architecture of using a common core and provided basic mapping workflows. That was the 100.0 release. And then with update 1, we added support for the 2D WebGIS, so sort of using web maps and layer items from portals, and introduced 3D support for mobile devices. Specifically in the last year, we've had 3 releases, 100.2.1, 100.3, and 100.4. And all of the capabilities released in those specific versions is available, like I said, across all the different runtime SDKs. So runtime's really evolving, and there's a lot of work going into improving it and making sure that it meets your needs. So come talk to us about what are some of the features you need to build your apps, and we'll make sure that we prioritize the right way so that we can deliver those for you in releases coming out later this year. In fact, we have a release that's almost done. The 105 release will be out end of the month, hopefully. But then we have a few more releases in the rest of the year. Last year, we added support for mobile map packages and improved the way we work with local tiles and raster data inside mobile map packages. We also added support for some offline analysis based on transportation networks, such as finding a closest facility or deriving a service area, which is basically drive times of areas you could get to. And all of that works offline. We added support for web scenes. So now you can author these scenes using ArcGIS Online or Enterprise and then consume them very easily in your runtime-based apps. And we improved some of the 3D workflows, like being able to identify and select features in 3D layers or do distance measurements, and also support a variety of different data formats like KML and Mr. Sid raster. We added support for some symbology types, specifically the military symbology, app 6B and 6D, and improved support for arcade expressions that are used all across the platform for things like symbology, to pop-ups, to labeling. And we also improved our support for feature layers and allowing you to do edits within a transaction and page through results and better handle subtypes. So, there are a lot of capabilities in runtime, and one of the best way to experience those is using some of the sample viewers that we provide. So if I go ahead, the code for the sample viewers is available on GitHub, but you can also download the iOS sample viewer from the App Store. Just look for ArcGIS Runtime SDK samples, and I'm going to go ahead and switch over to my iPad now. And here I've already downloaded the samples to my device. I'll go ahead and launch it. Just a second, I need to just update the settings on this so you can see the touches. So you can see we have samples covering a wide variety of categories for things like displaying maps, which is pretty basic, but also things like changing the background of a map. For instance, by default, you get a gray grid in the background, but you can easily interact with this and change the line width, size of the background grid, and also the color. And the great thing about the sample viewers is that if you like some of the functionality that you want to use in your own app, you can go ahead and dive into the code right in the app and see how easy it was to implement this and borrow code snippets from the app. And you can also get the code for this app from GitHub. To give you another example, here we have a map that you can sort of bring up a magnifier on and see better what imagery it's displaying. If I jump into the layers category, you'll see we have support for a wide variety of different layers that allow you to bring data from different data sources. So I can display things from tiles or, for instance, vector tile services. If I go ahead and launch one of these samples, you can see that the cartography and the symbology works really well on these native devices with high DPI, and it's really fast. So as I pan and zoom around, you can see I'm getting really good frame rate, and it's really fluid panning. And because it's all vectors which are being drawn natively on the device, you can see the labels stay face up as I rotate the map. So it works really well. Here's an example of support for KML that we added recently into the SDK. This is a map that shows some weather conditions across the country, and you can see that right now in the Santa Barbara County, they're experiencing flash flooding. And here's another sample that shows KML, which has network links. And this is live data showing flights in the sky around the Schiphol airport in Amsterdam. We've got many other categories, for instance, working with features. The display information has some really cool samples. For instance, this one that allows you to tap on the map to start sketching. And you can go ahead and select one of these vertices and move it around. If you wanted to sketch freehand, we have ability to do that, like sketch a polyline or create a polygon. And then you can go ahead and move it around or change its shape and things like that. And you can also undo and redo. So the question is, are these all widgets? Most of them are APIs, very high-level APIs that you can call that'll do most of the work for you. But we do have something like widgets that we call toolkits, and I'll show you that a little later on in the session. We've got samples that show you how to edit data, route and geocode, and also display 3D scenes that work really well on these iOS devices. And you can use fluid gestures to sort of go ahead, pinch, zoom in, and also tilt the camera. And not only do we have those samples on iOS, we also have them for the Mac. So I'm going to go ahead and jump out of this presentation. You can see this is an app that we built using the Mac SDK. It's got those same categories and a bunch of samples. Here, for instance, I can do some analysis on a scene. For instance, let's go ahead and load a scene. And I'm going to go ahead and tap on the map and then drag my cursor around. And what it's doing is it's computing a line of sight, which tells you whether a observer can see the target. And when the line is green, that means that they are both in view. But as I move behind this hill face, you can see that the target is no longer visible and the line of sights become red in that case. So this is all interactive. I can do very easily. I can also compute line of sight dynamically instead of interactively, just by looking at what features I have on the map and by defining an observer location. So for here, example, I have an observer perched somewhere on a building who's looking at a car going around the city. And I can see that right now the car's behind the building, so the observer cannot see it. But if I were to change the observer's height, then things become a little bit more visible. We have some samples that show how you can work with geometries. For instance, This is an example of a map that allows you to show geodesic distances between two locations, meaning it follows the curvature of the Earth. It is not just a straight line like you would have in a flat map. And again, you can see the source code for this Mac app just inside and see how we've built these samples and borrow heavily.
So are this code for the macOS and the iOS app, mobile iOS, both are same?
Yeah, so the question is the code for iOS and macOS the same? And the answer is yes. I mean, 99% of the code that you write for iOS is what you can use on macOS because we use the same types. The only difference comes when you work with the UI. Apple requires you to use different UI frameworks on iOS and Mac. So the button on a Mac is different from a button on iOS. But when it comes to ArcGIS Runtime APIs, the API is exactly the same. So that was just a quick tour about the different capabilities available in runtime that you can experience through our samples. But if you wanted to start building your apps with this SDK, what do you need? Well, first off, you'll need a Mac. Because the SDK builds on top of Apple technology, you need to use a Mac to build your apps. That's something that Apple prescribes. You also need to use Xcode, which is the IDE that Apple provides to do iOS and Mac development. You can download it free from the Mac App Store. And you can use Xcode 10 or you can use Xcode 9. 10.1 is the latest version. You can use that too. Any version of 10 or 9 is okay. You'll need to get a free Apple developer account so you can deploy your apps to a device for testing. And you'll need to get a free Esri developer account, or if you have an ArcGIS Online account, you can use that so that you can download the SDK and start using it. The latest version of ArcGIS Runtime available is version 100.4 that was released in the winter. Using that version of the SDK, your apps can target a number of different OSs. For instance, on iOS, you can target the latest OS, which is 12, and go all the way back to iOS 10. If you look at the latest stats that are published by Apple, just the two most recent versions of the OS, iOS 12 and 11, cover almost like 95% of the devices out there. So you're more than covered with these versions of the OS that we support. And for Mac, we support 3 versions going back to Sierra, but also support the latest Mojave version. And you can use either Swift or Objective-C to build your apps. The API that we provide you is an Objective-C API because Swift still does not have backwards compatibility, so we couldn't give you an SDK that worked from release to release of Xcode. We'd have to release it every time Xcode came out with a new version, but hopefully Apple's going to change that later this year. They've been targeting providing binary compatibility for a couple of years now, and this year they say it's going to be available.
So your ArcGIS sometimes will have support both Swift and ArcGIS?
Yeah, so we support both Swift and Objective-C. Quick show of hands, how many of you use Swift for your app development? And how many use Objective-C? Okay, there's a few of you. We still support Objective-C, so you can use that because it's an Objective-C API. All of our samples, however, are in Swift. We just can't bring ourselves to writing Objective-C code anymore. So where do you get the SDK from? Do any of you use CocoaPods? Show of hands. Some of you do? Yeah. So the SDK is available on CocoaPods. You just put the name of the SDK in your pod file and give it optionally a version number to pod install, and it'll download it and configure your Xcode project to start using it. It's pretty simple. But for those of you who don't use it, you can get the SDK from developers.arcgis.com, and you can download an installer package. Just go ahead and install that package, and it'll put the libraries on a central location on your Mac. And then when you start developing your apps, you'll need to configure your Xcode project, which is just as simple as dragging that library into the embedded binary section of your project. And that's it, you're good to go. So it isn't too much more work, but I do know that a lot of people don't prefer CocoaPods because it does a lot of magic behind the scene to configure the Xcode project. Just a note here, you'll see that when you install the SDK, depending on whether you use CocoaPods or the installer, it is a fairly large SDK. The libraries are little over 1 gigabyte. And the reason for that is the library that we provide, because it supports all the way back to iOS 10, we have to support the 32-bit architectures, ARM v7, and also the new devices, a 64-bit architecture. And the library contains binary for both of those. But because you use the library for development, and most of the times you're using a simulator, the library also contains some binary for the simulator. So there are 3 architectures in it. And when you add bit code to the mix for each of those architectures, it becomes really big. But that's just the size you will see as a developer when you install the SDK or use it in your project. When you compile your apps, all of that gets compacted and optimized, so your apps are nowhere near that size. The size of your app really depends upon whether you're deploying a universal app or a thinned app. Apple's recommending everybody go the route of a thinned app. The benefits are that when your app's deployed on a device, it only contains the architecture and the resources required for that device. And when you build a thinned app with the ArcGIS Runtime SDK, the deployment size of that due to the runtime is about 25 megs. And when it's installed on the device, it's about 75 megs. There's a great Apple technical Q&A. I put the number up there so you can Google it later, that talks about how you can thin your apps and how you understand the size of your app before you deploy it to the App Store. And that's what we've used to come up with these numbers. And these numbers change with each version of the SDK. As we add more capabilities, they sort of inch higher. But that's the size that we had with the 104 SDKs. So once you've downloaded the SDK, what do you do? Well, the best place for you to go is developers.arcgis.com. And there's a bunch of resources available there that I'll show you just now. So here we are on the landing page of developers.arcgis.com. You can see we have quick links to all of our different SDKs and the resources available for that. But if you just scroll down on the web page, you'll see that all of the capabilities that are available on the ArcGIS platform to developers, things like using ready-to-use maps and data to spatial analysis and working offline. If I go ahead and click on iOS to go to the iOS SDK homepage, you'll see that there are a number of dev labs that we make available. These are like short 10, 15-minute tutorials that you can use. For instance, how do you create a starter app? How do you add layers to your map? And there's a lot of information, background information of what you'll be doing in each lab. We give you a starter app that you can start writing code in. We show you all the code you need to write. And then we can also give you a completed solution if you're just lazy and don't want to go through the lab. You can just run it. So it's there. And then you can string a number of these labs together to sort of build a more functional app. So definitely check out the dev labs. It's a great way to sort of learn about how you can use the SDK. If I go back to the home page and scroll back up to the top, some place that you probably want to read through is the guide. We put a lot of effort into providing conceptual doc about the SDK. So we covered a lot of fundamentals. For instance, this one talks about what are the offline capabilities and patterns that you can use. And you can see that as I scroll, it's pretty involved because there are a number of ways you can do things. This one talks about our geometry model. You'll notice with the latest version of Runtime, our geometries are immutable. That means once you've created a geometry object, you cannot modify it anymore. And the reason for that is it allows us to get the best performance. If most of our engine, rendering engine and analysis engine don't have to worry about geometries changing on them, they can cache things and make some safe assumptions. The guide topics have code snippets that show you how to use some of those APIs as they walk you through the concepts. And then you'll see it's organized the same way that our sample viewers were, talking about maps, scene, displaying information, performing analysis. And then there's a section there when you are ready to release your app to think about how you want to license it and what are the different licensing capabilities and options available to you. You should also look at the reference section apart from release notes telling you what's new in every version of the SDK. We also give you information about things like error codes. So when you're doing something with the API and things fail, chances are you'll get a helpful message, but there are cases where there are no helpful message and all you'll get back is a code. So you can scroll through this document and look at the code and what the descriptions are. And we keep this document updated as we come across more codes that we weren't ourselves aware of. So it's a moving target. So that's the guide documentation. We have a really good API reference doc. For instance, here are all the classes. I think we had like maybe last count 150 classes. So there's a lot of APIs for you to work with. But if I look at one high-level class, which is layer, you can see that there's an object model diagram there that shows you all the different types of layers we have available. Scene layers, vector tile layers, feature layers, etc. And there's some really good documentation for all the properties on these things. So definitely check out the API reference doc. We put a lot of content in there that you need to know about. We also have information here about what APIs are available at what license level, so that as you're developing, you can, when you're developing in developer mode, you have all the APIs work. It's only when you go to deploy that you need to worry about licensing. So this information puts it right front and center for you. We have a tab that sort of shows you all the samples we have, the ones that I showed you in the app. We also provide them on the website in case you want to search for them. And then also check out the support forums. There's a lot of good discussions happening on GeoNet where users like you ask questions and members from the dev team sort of monitor those discussions and try to provide answers and ideas on how to do things. So definitely use that as a resource. But sometimes the best way to learn about the API is just start playing with it and get a feel for it. And if you download the installer package that I talked about earlier, what we do is we provide a playground project with that. And Playground's a new type of project that Apple's introduced in the last couple of years, which gives you a rapid prototyping environment where you don't need to build an app. You can just write some code and see the results for it in real time. So this is that Playground project that I was just talking about. So you can write a line of code and run it and see what comes back. So what I can do is I'll go ahead and create a point object. And I'll give it a lat long representing Palm Springs. And if I hit the play button here, Playground's going to evaluate it and look at my code and show me the result in near real time next to that statement. So here a point object's been created with that information. If I wanted to display this point on a web Mercator base map, I'll have to project it. So what I can do is I can use the geometry engine to project it. I'll go ahead and create another point that is using the geometry engine, and I'll call the project method. I'll take my original point, and I'll project it to the web Mercator spatial reference. And if I hit play, you can see now I got back another point which has different coordinates. This is in the Cartesian coordinate space. If I wanted to buffer this, I could say
You missed on that.
Thank you. And I can buffer it by, let's say, 5,000 meters. And this time, hang on. Got to force unwrap it. I get back a polygon. And then I can use the geometry engine to get the area of that polygon. And that's just a large number in meters. So it's a really easy way to start experimenting with our APIs and see what you get back. But many times what you'd want to do is you'd want to see a map. And the playgrounds allow you to do that a little bit too. So what I've done here is I've created a map view. I've given it a frame and given it a size of 400. And I've set the map view as the current view of my playground page. If I go ahead and switch to the assistant editor mode, and hit play, you'll see I get an empty map view. Then I can start adding content to it. Before I do that, let me just jump back to the slide. The latest generation of ArcGIS Runtime, the 100.x series, use a MVC pattern, a model view controller pattern, to differentiate between what you're seeing on screen and the data that you're working with. So typically what you do is you start with something called a map or a scene. And this represents the model component of that MVC architecture, basically the data that you're going to be seeing. A map's made up of base map, which provides context and is the lowest level that you see. And on top of that is some operational layers. The scene is very similar, except scene's also got a surface that sits below the base map to give it an elevation and terrain that you'd expect in the real world. And to display these things in your app, you need to create a map view or a scene view and give them that model component. So here we'd created the map view. Now what we'll do is go ahead and create a map. We'll set the base map on it. In this case, I'm using the topographic base map from ArcGIS Online. And I'll add an operational layer. In this case, I'm creating a feature layer that's connecting to this feature service. And I'll add it to the operational layers collection of the map. And then I'll set the map onto the map view. And there, I've got a map view in Playground that I can go ahead and sort of interact with. But if I want to zoom to a certain location in code, what I can do is I create a viewpoint with a center and scale, and then set the viewpoint.
Oh, you are not sharing your screen.
Oh, I'm sorry. I am on the right one.
You lost it from here.
PowerPoint. How's this? So let's do that again. So what I did was I basically created a map with some operational layers and a base map, and then I set the map on the map view. That's my map view that I can sort of interact with, but I can also set a viewpoint on the map view to go ahead and zoom into a certain location. So that's displaying a map, but if I wanted to display a scene, I just use a scene view and a scene instead. So let me go ahead and change this. I'll go ahead and change this to a scene view. I'll change this definition, this variable name, to a scene view. Instead of a map, I'll create a scene. I'll change this variable name to a scene. Set the base map, some operational layers, and that's it. And now, if I run it, oh, I need to change scene view.scene is equal to scene. If I run it, fingers crossed, I should see a scene view in my playgrounds. It's loading. There it is. There's a 3D scene view. I can go ahead and set a viewpoint, zoom in. The animation's a little choppy, and this is where playground sort of hits a wall. It's very hard to interact with it because there's a lot of graphics being used behind the scenes. So it's great for rapid prototyping, but not something you really want to develop your apps with when you're working with maps and scenes. So this is just a straight down view on a scene view, but I can go ahead and change the camera. So what I can do is I can set a heading of 180, so I'm looking south, and a pitch of 75 so that I have a perspective view on the scene. And now we've sort of tilted the camera, so we're looking at it in 3D space. But you can still see the world's pretty flat, and I can fix that by adding a surface to my scene view. Basically, I'm using this elevation service from ArcGIS Online. I create a surface and add it as a tiled elevation source and set it on my scene. And now you can see the hills behind. They have sort of a relief, and they're sort of elevated, so it looks like an actual 3D scene.
Is all over the layers you created?
Sorry?
The elevation layer, how extent is that? Like, I mean,
This elevation layer is provided by ArcGIS Online. We provide some world elevation by default. Yes, yes. But you can publish your own elevation using ArcGIS Pro and Enterprise. It's just an image service. So that's a quick tour of playgrounds and how you can rapidly write code and prototype with the SDK. But like I said, interacting with the map or scene is very difficult sometimes when a lot of graphics are being displayed. So what you really want to do is build an app. So you've seen this slide. Just a tip, when you build your apps, make sure you test your apps on actual devices, because the simulator can lie to you in two ways. One, the case you saw, it can make graphics look worse than they are because it's going through that simulated environment. Actual devices actually keep up with graphics a lot better. But it could also make your CPU-bound code look a lot faster because the CPU of your machine is very powerful and it might be able to execute multiple threads at the same time, but you put that same thing on a device and it doesn't work as fast. So you get false positives and false negatives. So the only solution is make sure you put your app on a device and test on that. Make sure you test with real people, not developers, because for developers, everything works, especially when they've written the code. And if you can find a user who will be using your app, try to get them and just see how they're interacting with your app, and are they able to navigate your app correctly? Are they finding all the important things they need to do their workflow without having to dig into the app? And then try to test your app in real network conditions, because if they're going to be using it in the field over a very limited 4G connection, then the Wi-Fi environment of your office is not going to show how that data loads for them. Okay, so with that said, let's build an app. I won't actually deploy it to a device because I'll have to faff around with the projector too much, but it'll be fine for the simulator for this case where we'll show you how to do it. It's pretty simple. It's a Hello World app. We'll add a map to an iOS app and add some geocoding to it. So here we go. There's my simulator. I need to scale this down. Okay, there we go. Anyways, so I have a storyboard open, which is empty. All I've got is a view in it. What I can do is go ahead and drag another view on top. The spinning wheel of death. Okay, there it is. I'll go ahead and use some auto layout to make it span the entire scene. Oh. And then I will go ahead and add a search bar to the top here. And I will go ahead and add some layout constraints to that. Equal width, and then okay, hopefully that looks all right. Then the last thing that I need to do is just make sure that I wire up my outlets and delegates correctly. So this one is going to be a map view, so I'll give it a type ArcGIS map view. And I can go ahead and drag it onto my map view variable to connect it. And then the search bar, I'm going to go ahead and drag it onto my search bar variable to connect that as well. Also, I need to hook up the search bar delegate. I'm going to go ahead and set that to my view controller. With that, I'm going to go ahead and jump into code now that my UI is set up correctly. And basically in the view did load section, I have that same sort of code, which is creating a map, adding a feature layer, and setting the map onto the map view. Let's go ahead and run this, see how it looks. Now my map views auto layout constraints weren't right, so it's here at the bottom of my view and there's some white space, but I have a search bar in the right place. Let me see if I can fix that. But before we do that, let's add some code on how to geocode. For the first thing I will need a locator task, which I've created. I'm using an ArcGIS Online geocode service, but if I have local data with a locator on disk, I can give it a path to that file on disk, and that way I can do geocoding offline. I've created a graphics overlay that's going to hold my geocoding results for later. I've added that graphics overlay to the map view. And then this is the method that gets called when somebody enters text into the search bar and presses done. So I want to write some code that'll go out and use the locator service to do the geocoding. Just quickly running through the code here. What I do is I take the search text from the search bar. I make sure it's not nil. And then I call the geocode operation on that locator task, and I pass in that search text. You'll see that after the geocode operation is an async operation. There's a block that follows it. That block will be invoked once that async operation is complete. So in that block, I've written some error handling code to see if an error happened, then just show some information. And if not, then go into the results that are passed into my block and get out the first result, add it to my graphics overlay, and set my viewpoint to that result. Let's go ahead and run this again. There's my map. I can go ahead and search for Palm Springs Airport. Hit enter. And there you can see it's geocoded the location and added a graphic onto my map view. I need to fix the map view because it's not positioned correctly. So let me just go back real quickly into the storyboard. Xcode, come on. You know what? Let me quit Xcode and start it up again. Something's going horribly wrong.
I think we all get simple pleasure from that.
Yeah. Live coding. Let's see. Does everybody know the command option escape? Yeah, okay, great. You guys have been there. All right. Okay, let's look at the constraints and see. Yeah, this shouldn't have 173 on top. Okay. Let's run that again. Okay, yay. All right, so my map's going underneath my search bar, which is great, and aligning with the top of the search bar. So now that we've geocoded, let's go ahead and jump back into our view controller and add some code so that when we tap on one of those features from the feature layer, we can display a call out and some attributes in there. The first thing I need to do is set the touch delegate for the map view. So this way the map view will inform my view controller whenever user taps on it, long presses, or does a different kind of gesture on it. Then the next thing I need to do is implement the delegate method that will be called when a user taps on the map, and that delegate method is called geoView_did_tap_at_screen_point, and it passes in the screen point which the user tapped and also the map point in the map's spatial reference. What we do inside this method is we use a very nice helper method that the map view provides that says identify layers, and we pass in the screen point that we got back and a tolerance. And the map view goes ahead and looks at all the layers inside it and does queries and hit testing to find what features are available at that location. Again, it's an async method. So when it's done, it invokes this block, passes the results in error. We dismiss the call out if we were previously showing it. We do some error handling. And then we go into the results and get the first feature out of it. Then we set the callouts title to an attribute from the first feature called name. And we set the detail to a value from the attribute called text for short description field. These are the attributes that the feature service sends back with all of its features. And then we call the simple method show on the callout to display it. We pass in the feature for which we're displaying it, so it's anchored correctly on top of it. And we also pass in the map point. So if I go ahead and now and run the app, now when I tap on one of the features from the feature layer, I should be able to see their information in a callout. So I go ahead and tap on this guy, and there you go, callout anchored right over that symbol with a name and detailed description. The next thing I want to do in my app is display my location on the map and also route to one of these points of interest that I pick when I hit the accessory button. To do that, I'm going to go ahead and define a route task. Again, I've created a route task with a URL to the world geocoding service. I'm passing in some credentials from my ArcGIS Online account that I want to use. And I've created a graphics overlay that will contain the results. And on the graphic overlay, I've set a renderer that will symbolize all the graphics I put inside it with a simple line symbol. The next thing I've done is I've gone ahead and set up a delegate on my callout so that whenever a user interacts with that button in the callout, I get notified so that I can route the user to that location. I've also changed the accessory button to this nice routing symbol instead of that bland information symbol. And I've started location display on the map view so that I can display my location on the map. Now what I want to do is perform the actual routing when a user hits that accessory button in the callout. This is the method that the callout will call, did tap accessory button. What I do inside that is I pull out the geometry of the destination feature that I want to route to, so I get the point back. I initialize my route parameters. And then I set the stops from my location that I'm coming back from my location display and the destination location which the user tapped on. And then I call solve route on the route task. I pass in my parameters, and again, there's a completion block that gets called when that async operation finishes. And it's got the result, hopefully a route or an error if something went wrong. I do some error handling. If there's nothing wrong with the error, I go into the result, get the first route. I get the geometry of that first route. I add it as a graphic to the graphic overlay, and I set my viewpoint to that route. And then I can also print all the directions in the console. I'm not going to display them in the app. So let me go ahead and run this. I get prompted that the app wants to use my location, which is all right. There's my location on the map. I'm going to go ahead and pan away, find a feature, tap on it, and then hit that accessory button to perform a route. And there's my route. It's displayed as a line on the map. You'll see that the line's actually going underneath the search bar because it's going till the edge of the map. You might have UI like this. There's a pro tip where there are things overlaying your map. And you want to make sure that when you set viewpoints or you zoom to areas, they're centered in the unobscured portion of the map. So for that, we have a property called content inset, which you can set up as in this case, I'll give it a top edge that is just below the width of the search bar. And so that way now, whenever I call set viewpoint, the map view is going to make sure that that viewpoint is adjusted in the unobscured portion below the search bar. And there you go. So it's just right there instead of at the top of the map. Even this, though, is too close to the edges of the map for me. So what we have is we have an overload for the set viewpoint method that can also take a padding. In this case, I'll give it a padding of 25 points. And so it'll give some breathing room around that area of interest that we want to zoom to, and it won't go from edge to edge. And there you can see there's a little bit more space on either side of the route. So very quickly, using locator task, the route task, and a call out, we've been able to build this type of an app. So we looked at how we work with maps and map views, how we work with storyboards and add views to that, how we use the locator task, graphics overlays. I talked about the task pattern, like the geocode method, which is async. There's a callback block that's invoked with the results and errors. You look at the errors first, make sure everything went okay, and then process the results. There's more information about tasks and jobs that I won't get into right now. Everything that we've seen so far has been small one-shot operations that come back quickly, but there might be some operations that have multiple stages, such as downloading a map. Those are longer runs, and for those cases, we have jobs which allow you to inspect the progress of that job on the server, serialize it to disk so that if the user quits the app and comes back, you can get the results of the job when they're finished on the server, when your user was not working with the job. And we have a lot of examples that do that in code on the website. Something to think about is threading. We have a pattern that we follow, which we use to make sure we call back on a certain thread that you expect. Basically, if you invoke the operation from the main thread, we'll call back on the main thread because we're expecting you probably want to update the UI. But if you called that operation from a background thread, then we will call you back on any background thread, because we assume you don't want things to happen on the main thread. If in that callback you now want to do some UI work, you'll have to make sure you dispatch back to the main thread. Otherwise, your UI will not update. There's a blog post we wrote about how threads work with the ArcGIS Runtime SDK. I have a link to that. It's in that GeoNet community space. My colleague Nick Furness did a really good job of explaining that, and I recommend you give that a read. It's really simple rules that we follow, and we think those rules will actually fit in fine with your development workflows. We looked at how we added some feature layer to the map. We did interaction with it by tapping on a feature, showing a call out. And we did some routing and did some viewpoint adjustment using content insets and padding. When you're working with location display, many times you want to simulate location. Xcode provides a great way for you to set a custom location, but many times you want to simulate along a specific path. The SDK provides a couple of data sources for you that can simulate locations based on information in a GPX file that you might have, or a route geometry polyline that you might have created. And there are a number of autopan modes that we provide that automatically recenter the map as the location changes. Finally, I just want to point out some more resources we have for you. Toolkits are a great way. Those are sort of like the widgets that somebody was asking about before. We provide the really high-level UI components you can add to your app, and we have things for Compass and Scale Bar and Legend, and they really simplify your app development, and they're open source. You can get them on GitHub, and you can then modify them to match your app's look and feel, or add a little bit more to it, depending on what you want to do. And if you just want a full-blown app that you can start customizing, then look at our open source or example apps. You saw a couple of them in the plenary this morning, the data collection app and the DSA app. We have a couple of other iOS apps like Mapbook and Maps, and we provide all the source code for GitHub, and they really target a specific workflow that you're trying to build into your apps. So check those out on developers.arcgis.com. And finally, there's a lot more sessions on Runtime that deep dive into specific areas that I haven't gotten into in this session. I encourage you to check those out. We have a release that is coming out in just a few days, hopefully by the end of the month. We call it Update 5. It'll have a lot of new features, and we'll talk a little bit more about those features in the road ahead. So make sure you check that out. Finally, I want to give you just some heads up on deprecations. We've decided that we'll be deprecating the macOS SDK for Runtime, primarily because of two reasons. A, we don't see a lot of adoption of it in the enterprise space. How many of you build apps for the Mac? Oh, are you sure? One guy, all right. But 105 will be the last release of the macOS SDK. And then after that, we'll look into something that Apple's announced where they'll allow iOS programmers to bring their iOS apps to the Mac. We hope to sort of build on top of that and allow those workflows. So we'll see where Apple takes that, and we'll be following closely behind. And then Apple's deprecated OpenGL last year. All of our graphics is built on OpenGL ES, but we have been working on trying to move it to Metal, so that's just gotten more momentum after Apple's announced its deprecation. So hopefully in a future version of Runtime not too far away, you'll see a version of the SDK that does all its rendering using Metal, and you won't be impacted by the deprecations. So that's all I had for you. Thanks for your time. And you have the events app. Please give us feedback on how you like the session, what you want to see next year. We take your feedback really seriously. And have a good conference.